All right, I'm here. All right, hey Ruben, how's things? Oh, hold on, I got the wrong screen up. I had to turn the lights on, get some water, all that kind of stuff. But I wanted to be here at 1 o'clock, so I'm here. Ruben's here. How's things, Ruben? Hey, happy birthday, Omar. Hope you're having a good birthday, all things considered. Mine's coming up in a couple of weeks, and it's gonna be a little weird, stuck at home, and then also. Something that's weird about my birthday is I'm the oldest grandson, right? Oldest grandson of my dad's parents. Anyway, I'm like the third oldest. Hey, Mariana, I'm the third oldest on my mom's side. But on my dad's side, I'm the oldest grandson, and my grandmother has the same birthday. So she and I share the birthday, right? And one of the freshman students this year also has it. Oh, dude, I get you, Ruben. I get you. That shuffle's tough. So, anyway, my birthday coming up this year, which is in a couple weeks, is the same as my grandmother's, but my grandmother died over the summer. So it's going to be my first birthday of my entire life where I don't share my birthday with my grandmother. Then being stuck at home on top of it, I don't know, I might just be sitting at home the whole day feeling sorry for myself and stuffing myself with chocolate cake and getting even fatter. Hope not. Hope not. But yeah, so that's going to be a little bit of a strange situation. But I hope you are having a decent birthday. I hope Ruben had a decent birthday last week. Yeah. Let's see here. Yeah, I know, right? It'll be all right though. We'll get through it. I would rather have had those times than not, if you know what I mean. Like we had a lot of really good times. So mostly it's happy and it's okay. It's all right that. Whoa, I got some. There we go. It's okay that all that happened. So Vanessa's here. Hello, Vanessa. How's things with you this afternoon? You guys all ate lunch? Hey, for Mr. Faulkner's class, I saw the other day and today a lot of you guys are doing stuff with Mr. Faulkner, and I saw something like he's using the Google Hangouts. How do you guys like that? Can we get an F in the chat? Wait, what, Ruben? Can we get an F in the chat for Mr. Brown? I don't know what that means. Huh. Like I deserve an F? I don't understand. You'll have to tell me, Ruben. All right, so tell me how things are going on with Mr. Faulkner's. I think he's using Google Hangouts. How's that working for you guys? Good, bad, what? Would you prefer using that to this? All those kinds of things. Because I'm just trying to figure out what's best and what's easiest, and this is new for me and for everybody else. All right, so let's go ahead and get to it. We're about 4 minutes in. So here, when I post it, I'll remember. 4 minutes. We're about 4 minutes in, and let's go ahead and get to these homework assignments. So we had these two things right here. You were supposed to find the domain and range, and I think. Oh, I didn't know that, Ruben. Press F to pay respects. That's weird. So Ruben, what we were going to do with our homework is we were going to be finding the domain and range for these, and we were going to try to do it algebraically first, and then use Desmos to check. Yeah. Yeah, so that's what we're going to do. So Mariana says that she actually thinks it's pretty cool. Ruben says it's kind of awkward because he doesn't have a camera on his computer. Yeah. Hold on. Before we do the homework, let's go ahead and talk about this real quick. Hey, Davey boy. So there are a couple of ways that we could have like a video conference. I don't really like Google. I don't like much of the Google stuff. I used to, but it hasn't kept up with changes in technology. Zoom is way better. Google Hangouts gets really buggy. You get more people in there. I prefer Zoom. I like this because you don't need special software. You can use your phone. You can use your computer. You can watch it again later. So if you're not here, it's easy to just post it. It's already loaded on the internet. I don't have to upload it and wait for all those kinds of things. So this is super, super easy for all of us. That doesn't mean it's the best, but it's easy and it's accessible. So that's why I prefer using this. But maybe we'll try something on a small scale with one of those others. We'll talk about that later. All right, so let's get to the homework, shall we? So the first one, 3 minus the square root of x, and then that plus 1. So check this out. When we're talking about domain, let's see if you guys can see all this, right? The square root of 3 minus x plus 1. We're talking about domain. Domain is the set of all possible inputs. So we're trying to figure out, really the way we try to figure this out, right, is we try to figure out what can't you plug in. Like, what numbers could you plug in for x and you don't get a number back, or a real number? So with square roots, if you have a square root of a negative, then you have a problem. That's not going to give you an output. So if you plug in a number that gives you a negative square root, you don't get an output. So like here, if we were to plug in, like, say, for example, anything like a 5, if we plugged in 5, it wouldn't work, right? Because 3 minus 5 is 2, and you'd end up with the square root of negative 2. Right? Plus 1. Well, this part isn't a number that's on the xy coordinate plane, so you can't add 1 to it, so it's obviously not there. So the thing we said to do is take that radicand, right? And we want to figure out what values of x would make it negative. Negative numbers are less than 0, right? So we want to figure out what numbers for x would make this negative. And these are the things that are going to be in the not domain, if we wanted to call it that, right? So negative x is less than negative 3, so x, anything greater than 3, doesn't work. And that makes sense, right? Because if you put in like a 3.1, if you put in a 3.1, well, you would get the square root of negative 0.1. That doesn't work. Yeah? Hey, Nelson, how's things? You guys doing okay over there? I know you got 5 people in your family? Man, that's got to get kind of crazy when you're just kind of shut down for a while. Although, I imagine your dad's probably still working, right? He gets to leave and come back. I say gets. It might not be a good thing. Might not be a bad thing, but, whatever. So when we're doing that, if what we're looking for is what doesn't work, right? So we take that radicand, set it less than to 0, because that will tell us what value of x would make it negative, and those are the things we can't use. So the opposite set of numbers is what makes the domain, right? So like, hold on, there we go. So this doesn't work. Anything greater than 3 doesn't work. So the domain of this would actually be, x is greater than or equal to 3. No. X is less than or equal to 3. My fault. I'm sorry. The opposite set of numbers. Because if you look at a number line, right, here's 3, right? Anything greater, anything this way doesn't work, but everything that way does work, right? So if x is greater than 3, we have a no. If x is less than or equal to 3, we have a yes. Yeah. Hey, Alicia. How's things going with you today? Hope you guys are having an okay time with all this. Settling into a rhythm, all that, right? All right, so domain for this, we're going to say anything that is less than or equal to 3 works. And if we were going to do, like, let's say we were going to do a t-chart, and we started plugging in numbers, what we'd end up seeing, if we just had this part, 3 minus x, what we would end up seeing is, here's 3, we'd end up seeing a graph like this. This is just for the square root of 3 minus x, right? Do you guys know what the 1 does? This one right here, when we add 1, do you guys remember? You can kind of think about it from a quadratic equation. Hey, Paula. So, like, do you guys remember if you had this, and we had, like, say, x squared, and then we added 1 to it? X squared looks like this, right? With this plus 1, every single coordinate gets 1 added to it, so it would be 0, 1. And, like, let's say this was 2, 4. Well, when you added 1 to it, it would become 2, 5, and so on. So this would get moved up 1 spot. Same thing here. It would get moved up 1 spot. So the range, I'm going to guess that the range would be from 1 to infinity. Ugly infinity sign right there. Hey Chris, how you doing today? How's this kind of newish math hitting you? You doing all right with it? Yeah, I kind of miss being in more than kind of. I very much miss being in class with you guys, but we're making the best of it. So let's go ahead and do this. So we're guessing this is the range, and we're guessing that this is the domain, right? So just to be clear, we're going to say that the domain is anything greater than or equal to 3, and the range is 1 to infinity. We could also say it this way: y is greater than or equal to 1. Right? So we're saying that. So what we're going to do is we're going to go use our good old buddy Desmos over here, right? So let's go ahead and do that. Let's transition. There we go. Here. There we go. Here is Desmos. So our equation was, let's see, the square root of 3 minus x, and then we had a plus 1 at the end. Did I do that right? Oh, 3 minus... I made a silly mistake. Do you guys see what I did? Here, let's take a step back. I got myself confused. Oh, I am so silly. Man. Do you guys see what I did right there? Man, my spider senses were tingling. In fact, I was thinking about, this is funny. I didn't do it on purpose, I promise. But it's exactly the question that Angela asked about on Friday. Do you remember? I told you that, I was really excited that she asked the question, because I said this is what everybody messes up. And it might not be confusing yet, but it's going to be confusing. And boom, here I go. I messed it up. So let me go back. Let me go back to the document camera and let me show you where I made my mistake. So I've got my work right here. You see, there's my work right here. And this is exactly where I made my mistake. These are the numbers that don't work. Nothing less than 3 works. On a coordinate plane, this is 3 right here. Nothing less than 3 works as an input, but that doesn't mean the graph's not over here. Or nothing more than 3. So nothing over here. Not here. I said it backwards right there. I apologize. So, look, we found out what doesn't work. Nothing over here works, right? But all of our inputs go this way. So I had my graph backwards. I messed it up. I should have actually done a T-chart. I shouldn't have messed it up to begin with. But I don't know. As is always the case, I don't do the problems ahead of time. I try to just see what happens. And if I get confused, then I kind of share with you how I think through it. And if I make a mistake, I show you how I try to learn from it. And I know better than that. But anyway, this is backwards. Dope. And I wish I had a Homer Simpson thing right now. So this is backwards. So let's start over. Look. Here's what we got. 3 minus x plus 1. And so what we're going to do is we take the radicand, make it negative, and we just found out that this is what doesn't work. This is the not domain, right? You can't put anything in more than 3. So on a graph, like if this is 3, there's going to be nothing this way. All of the answers, everything on the graph is this way. This is the way the domain works, is this direction. And so the graph, if it was just the square root of 3 minus x, that's what I kept mixing up actually. I think I did this in my head, which is different. But the square root of 3 minus x is that way, right? So the domain is definitely from, we could say it this way, negative infinity to 3, or you could say x is less than or equal to 3, right? All right, so I apologize about that. Let's see how you guys are doing. Good. Let's see here. Good. I'm glad you guys are doing all right. All right. And Dida's here again. Hey, Dida, how are you? Hope everything's going good with you, too. So, domain is from 0 or negative infinity to 3, right? Or x is less than or equal to 3. So you can put any number you want in when it's the square root of 3 minus x. Any number you want that's 3 or less, you get a real number, or you get a number that works. Because, well, here, watch. Just to be clear, just to make 100% sure. And this is what I really should have done when I was kind of thinking about it. I really should have just done a T-chart like this. Like, look, we can plug in 3. When you plug in 3, you get 0. You plug in a 2, you get the square root of 1, which is 1. You plug in a negative, let's say we plug in a negative 6. Well, 3 minus negative 6 is 9. Square root of that is 3. Do you see? So we have all these points to the left of 3, and all of those work. Do you see what I mean? Now, this was, of course, just for 3 minus x, right? Which we kind of talked about last week. The part that was new was this part. What does that 1 do? Do you see how there's a plus 1 at the end? So when you add 1, this is what you get. Do you see what I'm talking about? So the range, the smallest number you're going to get, this is going to be your smallest output right there. That's your lowest point. That's your minimum value. And so the way the graph's actually going to work is this point right here is going to be 3, 1. And it's going to go that way. Kind of like the upper half of a sideways parabola. Yeah, I'm doing good, Dida. Thanks for asking. Other than messing this up, embarrassingly so, I'm doing all right. Actually, it is kind of weird. You know, I don't mind making mistakes in class with you guys. Sometimes they cause some confusion, but I really do believe that it's better. And I know that as a student, I had professors, math professors, that would make mistakes on occasion in class because they wouldn't rehearse the problems they do. They make up problems off the top of their head, all that kind of stuff. And they said they did so for the same theory, same reason I share with you guys why I do that. In fact, that's where I got the ideas to do that, and I just thought it was really great. But on a video, it's kind of embarrassing because, well, I don't know, it's there for everybody to see forever. But that's okay. It's how we roll. It's what I think is best. So I messed that one up at first. What are you going to do? All right, so let's take a look at the screen capture. Let's take a look at Desmos here. All right, so this is what we were talking about, 3 minus x. And if we did the square root of 3 minus x and then outside plus 1, do you see? Right here is our minimum. That's where we start. I don't know why it's not lit. I guess I have to do it this way. Oh, that's 3.1. 3, comma 1. And let's label it. So do you see, for the equation we had, the domain is going to be from negative infinity to 3, or x is less than or equal to 3, and the range is from 1 to infinity. So yeah, there we go. Let's see. How you guys doing with that? Pretty good? Yeah, so Paula, that's a good question. She wants to know if when we're finding the domain, we just worry about the radicand. And for this kind of situation, absolutely. Because there's only one x is the input, and x is inside the radicand. So we don't have to worry. That's all we have to worry about. Everything else just gets added or multiplied to whatever the radicand simplifies to be. Does that make sense to you guys? Yeah, so just worry about the radicand. All right. Range is a set of outputs. That's a little trickier. You might be able to figure it out, but if you get kind of a visual idea just by using Desmos, I think that's like more than sufficient for what you guys are going to need, okay? All right, let's do the other one, and I'll try not to mess this one up. All right. So, let's see here. Let me switch to the document camera. There we go. So the second question we had was this one. We were supposed to find the domain and the range of this. 5x minus 4 minus 7. Okay, I have a healthier respect for finding the domain and range of these now that I messed up the one before. I'm going to really try not to mess this one up, which means I probably will. Because that's how it goes, right? It's Murphy's Law. Now, but I think we'll get it. Here, let's do it to it, shall we? All right, so look, the x, the input, domain's the set of all possible inputs. The input's inside the radicand. It's inside the radical symbol, right? So it's the radicand. So what we got to do, we've got to figure out what values of x would make this negative. Less than 0 is what negative means, right? All negative numbers are less than 0. So when we solve this one, we get 4/5, right? We're going to add 4 to both sides, then divide by 5, right? So anything less than 4/5 does not work. So our domain is actually the opposite of that. It's going to be x is greater than or equal to 4/5. So like on a number line, if this is 1, 4/5 is right here. On a number line, everything this way will be on the graph, and nothing to the left. Everything this way will be on the graph. Everything to the right of 4/5 is going to be on the graph. Nothing to the left of 4/5 will be on the graph, right? Okay, so there's our domain. Now, let's do it. Let's do this. Check this out. Watch this. I'm going to say 5x minus 4, right? And then we're going to do times -2, and then we're going to subtract 7. Watch, check this out. I'm going to see if this makes sense to you guys. So what I'm trying to do is show you what the -2 does to it. If you remember from trig functions, it flips it over, right? Watch. Let's go to Desmos here. I'll show you what I'm talking. I'll show you what I'm talking about here. We'll go to Desmos. Let me get it set up before I switch over. So I'm going to show you what that negative does and how A changes things, right? So here we go. Check this out. You guys remember this stuff right here. Sine of x. All right, so we got this sine of x, right? And you guys remember what happens if you put a number for the a, right? It doubles it or whatever. But we didn't really talk too much about what happens with this. If I make that a negative, what do you think is going to happen if I put, so I'm going to, here, watch, 2 sine of x. What's going to happen if I change this 2 right there to a negative? Do you guys know what's going to happen? Anybody got a guess what's going to happen with that? So when you take the a and you make it a negative, because when you have just a positive a, it just makes it go up, right? So what ends up happening actually is it ends up flipping it over. So here, let me show you that. So do you see? Let's close this one. In fact, if I just made it -1x, do you see? This is going up and then down, up and then down for one period. Well, negative makes it go down first, and if it was a -2, whoa, not 20. If it was a -2, it would go down by 2. If it was a -5, it goes down by 5. Do you see? So negative flips the direction. So that's one of the things that when we talk about, there we go. So when we talk about this -2 right here, that's what we're talking about. It's going to, instead of, so like, most of the time, those square root functions, they look kind of like this, right? Well, the negative is going to make it go like that. It's going to make it go down. And if it's times 2, it's going to be twice as high at every point. If it's -2, it's going to be twice as low at every point. So that's what that -2 is going to do. And that's what I wanted to show you, how that -2 does separate than the +7. So if you just plug the whole thing into a calculator, you get a bunch of outputs, but you don't necessarily learn how each of those things moves it. This is called transformation of functions. And actually, vertex form is really good at that. It's something we don't explore a whole lot in Cambridge because we don't get to use these graphing calculators, but it's something you'll do a lot in pre-calc. Certainly pertains. So let's go ahead and get to it, right? So let's go ahead and plug in. We can't plug anything less than 4/5 in. So let's plug in 4/5, right? Let's see. I would like to plug in some numbers that work out pretty easy. So like some square roots that are going to work out really easy. So like if I could make this a 29, right? So if this was like watch, check this out. If this was, let's see. Let's say it was 29 over 20. Yeah, watch. Let me show you what I mean. So when we plug in 4/5, like when we plug in 4/5, it's going to be 5 times 4/5 minus 4. Do you see how those reduce and you're left with 4 and you got 0? So I get an output of 0, right? When I multiply it by 2, I get 0. When I subtract 7, so my coordinate would be 4/5, comma, -7. That's my overall output right here, right? If the -7 wasn't there, it would be 4/5, comma, 0. Now, when I plug in 29 over 20, no, actually, no, 29 over 5. 29 over 5. I don't know what I was thinking. 29. When I plug in 29 over 5, look what happens. The 5's reduce, and you're left with 29 minus 4, which is 25, right? And the square root of 25 is 5. Do you see? And then -10 and -17. Do you see what I mean? Let's plug in, let's say, let's do this one right here. Let's plug in Let's do 6. So it's 36. So I want to be 40. I want to be 40. So let's do 40 over 5. So let's plug in 40 over 5. Do you see how I came up with that number? When I plug it in, the 5s are going to reduce. The 5s are going to reduce. And then 40 minus 4 is 36. And the square root of 36 is 6. So here's what I mean. If I did 5 and 40 over 5, right, minus 4, those 5s reduce. 40 minus 4 is 36. This is all in the square root. Square root of 6 is 6. Negative 12, negative 19. You guys see how I got those numbers right there? So here's what I'm thinking. If I keep doing these numbers, I'm going to see that my smallest output is negative 7, which is 1, 2, 3, 4, 5. 1, 2, 3, 4. Let's do 5, 6, 7. Negative 7. And 4/5 like would be right here. Do you see? And then when I plugged in 29 over 5, which is like just a little past 5. 1, 2, 3, 4, 5. It's almost to 6 actually. 8, 9, 10, 11, 12, 13, 14, 15. Right? So 16, 17, 18, 19, 20. There we go. Okay, so 4/5. 4/5. Let's say that's 4/5 right there. And then we get out a negative 7, right? So then we plugged in 29 over 5, which is almost 6, because 30 over 6 is 5, right? And we get out a negative 17. So that's all the way down here. And then this is 8. That's actually 8, right? Wait, something's weird here. 40. Yeah, okay. That's weird. Okay. And then we got a 6, and then that's all the way down here at negative 19. So it's going to look like that. There's something weird about this one. Hold on, let me check. So 5 times 40 over 5 minus 4. That's in the square root, right? Because 5 minus, that's 8. Oh, I see. Yeah, I could have just plugged in an 8. Duh. Yeah, either way. Either way, we're all good there. So let's go ahead and take a look at this on the graphing calculator. Negative 2. Well, here, let's do it this way. Let's do 5x minus 4. Let me check and see how we've got questions. Okay, hold on. Before we move on, let me see if we get questions. Hey, Vanya, how are you? So when is it going to start? Yeah, so Ruben wanted to know where it's going to start. It's going to start at negative 4/5, positive 4/5, comma, negative 7. Okay, so here's what we're going to do, boys and girls. We're going to put this on the document camera. What I'm going to do is I'm going to put in kind of how I did this T-chart. So we're going to put in just this column first, see what that graph looks like. We're going to see what the negative 2 does to, and then we're going to see what the negative 7 does to it. So we can kind of see all those. So let's go ahead and do that. So square root 5x minus 4, and that's times negative 2. Do you see how that made it go down twice as fast? And then negative 2, and then minus 7. Ah, there we go. I didn't have it zoomed in enough, or zoomed out enough. So the negative 2 flips it over and makes it like twice as steep, because if it was just a negative, watch this, if it was just a negative, do you see? It looked kind of strange when it's positive because it's hard to see that it's flipped over and doubled. But if it was a negative like that, negative 1, then you can see it doubles it. So like, for example, here at 5, we have negative 4.83. So let me... Ay. 4.83. 83. Oh, positive 5. There we go. Oh, well, what was it right there? 583. Okay, there we go. So you see how we've got, label it. Okay, so you see how we have this point right here, and that's without the equation being times negative 2, it's just times negative 1. So when I get to here, let's see, still an input of 5. Do you see how it got doubled? Do you see how it's doubled? Now, it's not exactly, like this is rounded, right? So these are rounded to the, what, the thousandth place. And so the rounded gets doubled and then rounded again. So it's not exactly perfect because double of 3 is not 5, it's 6, right? But yeah, so the value got doubled. Do you see what I mean? And then, so let's go ahead and type that in, 9165. Ah, there we go. And then if we subtract 7 from that, it should end up here. So watch, check this out. 5 comma negative 16.165, because all I'm doing right here is adding, I'm subtracting 7 from this negative 9, and you see it ends up right there. That's kind of cool. So the range for this one's going to be from negative infinity up to negative 7. Do you see? We can zoom out as far as we want. These are going to keep going down forever and ever and ever. It's going to go up to negative 7 for the one we were working on. Yeah. So playing around with Desmos like that's kind of cool. Do you guys, I mean, I think it's a good learning opportunity. I learned a lot messing around with graphing utilities as a math student, because sometimes just seeing it visually made it much more sensible to me than looking at all the algebra or the arithmetic. And then the visual kind of explains the arithmetic, because here, do you see we have, like, if we have an input of 5, that's what we get out. And then the 2 doubles it, do you see? So double of 4.583 is 9.165. And then the 7 moves it, the negative 7 moves it down 7 places farther. So it starts at negative 9, ends up at negative 16. So that's kind of how that works. Yeah. All right, so let me get caught back up on the questions. I can't see the questions when I have the screen capture on. How did I get the numbers on the table? Oh, okay, she got her question. Good. Hey, Hector, how's things? Yeah, Ruben's calling out tardies today. So that's kind of confusing. I don't know, maybe this lesson should have been something I typed up with the PowerPoint. I'm not really sure. It's just to give you, well, if you've got kind of an introductory idea for how you look at the radicands to find the domain, I think you're good to go. Yeah, and that's kind of what we were working on. All right, so next up, Buttercup. Check this out. Here's what we're going to do. We're going to look at some rational functions, okay? And we're going to look about, we're only going to worry about the domain. We're not going to really worry about the range on these, okay? Just the domain. So what I'm going to do, I'm going to switch us back over to the screen capture so we can see some stuff on Desmos, right? So here's what we got. Check this out, 1 over x. Do you see? Oh man, this is called a vertical asymptote. There's a vertical asymptote at x equals 1 because x equals 0, because you can't put a 0 in right here. If you put 0 right here for x, it's 1 divided by 0, it's undefined. And so you see x equals 1 right here in green is actually the only thing that's not in the domain. The domain is going to be from negative infinity up to 0, not included, and from 0, not included, up to positive infinity. In fact, we can kind of zoom out a little bit right here, and we can kind of look. Do you see this curve right here? It gets closer and closer to x equals 1, or x equals 0, the y-axis, but it's never, ever going to touch it. So do you see how the x value is getting smaller and smaller and smaller, and the y value is getting larger and larger and larger? Yeah, look at that. You see? And then as we keep going, I mean, you can go up as far as you want. It says 0 here. That's because it rounded it, right? And so to 3 significant figures. Oh, there we go. I was on the wrong line, you see? So that's a really small number for x, 0.039. So you can never put in a 0 for x into 1 over x because you can't divide by 0. And this is what it looks like. On the left side of x equals 0, it goes down infinitely forever, and on the right side it goes up infinitely forever. So the domain is going to be anything but 0. So let's do that on the document camera. Hey, Angela. I'm sorry, Angela. I didn't see that you were here, Angela. Angela, hello, Angela. You know what? I'm sorry, Angela. Hello. Forgive me, if you would, please. Be so kind. All right, so check this out. Let's say we had f of x equals 1 over x. Now, what we saw is that it looked, well, what we know algebraically is that x cannot be equal to 0. If you put 0 here, you're dividing by 0. You can't divide by 0 because nothing, well, it's like this. Look. Division really is asking a question. It says, what times the denominator equals the numerator? And so this equals 2, and it's true because 4 times 2 is 8, you see? You can divide 4 into 0 because this says 4 times what is 0? Well, that's 0 because 4 times 0 is 0, right? But the other way around, no bueno. This says 0 times what is 4? Well, that's not a number. It's not a number at all. It's not like imaginary. It's just not a number in the slightest. Not a number in the slightest. So that's why you can't divide by 0, just in case you forgot, right? So what we do is we take that denominator and set it equal to 0, and then we solve it. Take the denominator, set it equal to 0, and solve it. That will tell you your not domain. So like here, take the denominator, set it equal to 0. Well, it's already solved. This is your not domain. This is what doesn't work. Everything else does. So we find out what doesn't work, and by doing so, we find out what does. So this doesn't work, but everything else will work. That's how it works. Now, if we had one like this, yeah, you see? Do you guys know what the domain for this one would be? Do you know what doesn't work? Give it a shot. I think you got it, right? I think you guys know that x cannot be -1, so the domain is everything except for -1. So here's how you're going to write this. So like for not -1, you could say, and there's a couple ways to do this. You could say from -infinity, right, to -1, and from -1 to infinity. You could say x is less than -1 and x is greater than -1. There's other ways to do it too. There's other notations that we might end up having to introduce, but I don't want to do it yet. I think just the description is plenty good enough for right now. So how are you guys doing with those? Do you guys understand how to find the domain of these basic rational functions? If you want, yeah, let's go ahead and show you while you guys think about that. Let's go ahead and show you the screen capture of x plus 1. Oops. There we go. See how x plus 1 right here? This green line is x equals -1, and you can't plug in -1. It's never going to cross or touch that. The graph over here is going to go up to positive infinity. Over here on the right, it's going to go down to negative infinity. Do you see? Yeah. And it turns out that the range is going to have a hole. There's not going to be a 0. This could never be equal to 0. So like if you set this equal to 0, like for the output being y, and you set it equal to 0 and you try to solve it, you wouldn't be able to get it, because you would multiply both sides by x plus 1 first, and you get 0 equals 1. That's impossible. 0 doesn't equal 1. So yeah, you can't get that. So the thing we're really worried about here today is, do you know how to find just the domain? Can you just describe it for these kind of rational functions? So we're going to practice. Let's do just 3. Should be kind of short and quick for you guys. Let's see, document camera. So here we go. Let's do these 3. I want you to find the domain only of these right here. Let's do f of x equals 3 over x minus 4. Let's do f of x equals 4 over 3x plus 5. And let's do this one, 1 over 4x. Let's see how those work for you guys. You guys have to tell me. Oh, something weird happened there on my end right here. So you guys will have to tell me how that is for you, and all that kind of stuff. Okay. And then we could do ones like this too, right here. Check this out. You guys can use Desmos to do this yourself. Do you see what I have typed right here? 1 over x plus 1 times x minus 2. What do you think x can't be? See if you can figure that out. That's bonus. That's for fun right there. Okay. So let's see how we're doing. Yeah, you guys seem like you're doing okay with this. So just give those a shot, and we'll go over them tomorrow. We'll see how you guys do, and hopefully tomorrow, sometime during the day, we're gonna get a little bit more guidance on what it is how it is we're gonna assign grades and all that kind of stuff. But for now, let's just keep taking care of our own business and not worry about all those things, and just do what we're supposed to do, and we're gonna be fine. So, yeah. If you have questions, concerns, gripes, complaints, whatever, email me. Send me a message. Actually, I prefer, if you have something you want private, like you don't want everybody to see it like in Google Classroom, I would ask you not to send it as a message in Google Classroom, because that gets a little funky for me. Like, I can't check it on my computer. It just says, when I click on it to respond, it says that the classroom's not found. So that kind of sucks. So if you have something for me that you don't want everybody to see, like you have a question, you're embarrassed by it or whatever, just send me an email and I can get back to you. Anyway, hope you guys have a good day. I will see you guys in the morning. We're going to go over this and we'll start with something new. All right? I'll talk to you later.